Now you know how to do some cool things with regular expressions, but let's be honest, right now you don't know how to swing in on a rope, tap some keys on the keyboard, and then save the day. After today, you'll know how to do pretty much everything in terms of the basics of regular expressions. In the next lecture, you'll learn how to do the actual replace in the find and replace, and at the end, you'll learn a few other random cool things. But first, let's review what we did last time. Whenever you want to use grep, you just type grep, followed by a pattern, and a pattern is jargon for an actual regular expression. So when you have a pattern, you are looking at all of the text that matches that pattern, and then you have the file or folder where you're actually doing the search. So what are you searching through? Grep is just one tool that lets you do regular expressions, but this same stuff can be done in any other regular expression engine. The pattern is what we're going to be focusing on. So the pattern can just be a literal. So if you want to search for hello, then that works. If you want to search for something that has a space or any other special character in it, you'll need to put it in quotes so that your shell doesn't expand it. So like if we wanted to say hello world, and we did it without spaces, without quotes, then the shell would interpret the space as separating another argument, which is not what we want to do. If we wanted to do anything that was a little bit more advanced, so anything that included a wildcard character, or anything that included any number of characters, the wildcard is the dot. So if we wanted to search for something that matched snack or smack, we would do s.ack. And if we wanted to, and we should put all of these in quotes from now on because the shell will interpret a lot of characters. If we wanted to search for one or more of a character, we would use the star. So n star will search for 0 or more n's. If you want to do one or more, you just have to use a plus instead of a star. And all of these we would need to specify a file. But to do anything really advanced, you might not want to just do it over every character. You might want to specify just a few. To do that, we use ranges. If we want to search for one of several characters, then you just put the characters in brackets. So if we grep for s bracket ack, not s bracket ack, s bracket nm, close bracket ack, in tcp.c, and this is the same file that we were using last time, then it will match snack or smack, but not anything else. So here you can see we got snack and smack. If we did this the same way as last time, just s.ack, that would match any character, and you can see there's also a stack in there. If we try to do a range that only includes a few characters, then we can do it just by enumerating all of them. So like if we wanted to do it with n, m, or t to match snack, smack, or stack, then this would work. If we wanted to just match one character, we could do it like this. Just put the one character in the brackets. But let's say that we want to match any number. Now, we do know how to do that, right? So we just have to go bracket 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember to close the bracket. And you can see that works. It matches all of the lines that include any number in them. But that's probably not the funnest way to do things. As a solution to this, we can use a range that actually includes an intelligent range. So instead of enumerating every character in the range, you just use a hyphen. So if we say 0-9, you can see that that gives us the same output as when we searched for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 way up here. So if we use the start of a range hyphen the end of a range, it will include everything in that range. A very common regular expression that you'll see is a through z, 0 through 9, because this is saying allow any lowercase character, i.e. any lowercase a through lowercase z, allow any uppercase character, uppercase A through uppercase Z, and allow any number, 0 through 9. And that will match any line that includes any character on it. So it won't include the lines that are just a blank space, but it will include every other line. We can also use this as much as we want in order to do things like find zip codes. So for instance, if we wanted to do anything that included any 5-digit number, we would just have to do 0 through 9, 0 through 9, 0 through 9, etc. And this would get us any 3-digit number, but I'm already tired of typing that. Let's say that we want to do something a little bit more exciting. So for instance, we want to get any 5-digit number. In order to do that, we just use a range. Not a range, a repetition. Repetition, you put something in curly braces, and then it will repeat that thing a certain number of times. So 0 through 9, it will match any character between 0 and 9, so any number. Curly brace 5 will say, do that 5 times. So grep 0 through 9, curly brace 5, will find the two things that look like zip codes. So int zip code equals 97424, and the address of GNU. What if instead of wanting to find every number, instead we want to find every character that isn't a number that's repeated 5 times? So we could do something like A through Z, but that would still leave out things like pluses and minuses and parentheses and stars. If we want to match any character except for something, we have to use a range inversion. The way that that looks is you do a range, and then you put a caret key as the first key. That says match everything except for what you're about to see. So if I say caret 0 through 9, and then repeat that 5 times, then that will match any line that has 5 characters in a row that are not numbers. And again, you remember to specify the file that you're searching over. So you can see it still has lines that have a bunch of numbers on them, but there isn't anything that doesn't have a long string of characters that isn't numbers. Now let's say that we want to use this repetition thing to get hello 5 times. So instead of 5 digits, we want hello, 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 hello. Let's see how that works. Grep hello bracket 5. That's certainly not what we were expecting. It has a line that's hello, but it is not hello, 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 hello. That's because what repetition does, and what most things in grep do, is they look at the one previous character. So repetition says take the one previous character and repeat it 5 times. The one previous character to the curly brace 5 was the O, which means that it's repeating the O 5 times. That's not really what we were expecting. What we wanted was doing hello 5 times. In order to achieve this, we need to group the letters together. So for instance, if we want to say hello, 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 we will use the parentheses, which is the grouping character, and we will say group hello, repeat 5. And then we can see car star hello equals hello, 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 hello. Exactly what we wanted. In general, you can use the parentheses whenever you want grep to treat something as one thing. This will be even more important when you do find and replace, because you'll want to rebuild the line using groups of characters. And in order to specify the group, you'll need to group it together in parentheses. You already know how to find a line that has 5 characters in a row that are not numbers. What if we want a line that is all not numbers? We don't know how long the line is, so given what we know right now, that would actually be pretty hard. In order to help solve this problem, there are 2 more characters that you should know about: the start of line character and the end of line character. The start of line character is the caret, or the thing that you might be used to as the exponent, and the end of line is the $sign. You can imagine that the start of line character was inserted immediately before the very first line in the file, and that the end of line character was inserted right after the very last character in a given line. What that means is that if you have a line of text, so for instance, let's go into tcp.c. If you have a line of text, then between here and here, so right to the left of here, there is an imaginary caret character marking the start of the line. And at the very end of the line, there's an imaginary $sign character matching the end of the line. We can use these if we want to specify something that happens at the very beginning of the line, at the very end of the line, or if we want to specify something that operates over an entire line. So let's say, for instance, that we want to find all lines that are functions that return an int. We can't just grep for int in tcp.c, because that'll give us every line that even uses an int. That's not what we want to do. Instead, we want to grep for start of a line int in tcp.c. And you can see that only gives us 3 lines, which are the 3 functions that return ints. In other words, exactly what we wanted. If we want to search for the end of the line, then we just have to do the same thing, except for use a $sign at the end instead of the caret at the beginning. So for instance, if we want to find every line that is a normal statement, so it's not a for loop or something, so it's a line that ends with a semicolon, then we could just grep for semicolon $sign in tcp.c. And you can see that matches a bunch of lines here that are regular expressions, or normal expressions I should say, since we're dealing with actual regular expressions. But it doesn't give us anything that's like a for loop or that's an opening method, because those don't end with a semicolon. They might have semicolons inside of them. For loops probably do have semicolons inside of them, but they do not have the semicolon as the very last character like all of these examples do. Knowing the start of line and end of line characters is especially useful when you want to do something over an entire line. To operate over an entire line, you need to say, I know what the start of the line is, and I know what the end of the line is, and I want you to match everything in the middle. So for instance, if we want to match any line that does not have a number anywhere inside of it, we couldn't just say what we did earlier, which is not 0 through 9, because that will match any line that has any character that is not a number. And you can see this has some characters that are not numbers, but it has other characters that are numbers. Instead, what we have to do is say the start of the line is here. After the start of the line, there's a character that is not a number, and that's followed by 0 or more of that same character. So here I have 0 or more characters that are not a number. And I know that immediately after that last character that is not a number, there's going to be the end of the line. And you can see here we don't have any characters, any lines that have numbers anywhere inside of them. In other words, exactly what we want. The reason that that works, just to review, is you can see that you have to match the entire expression when you're doing a regular expression. So you have to have a line that completely matches this. In other words, the line has to start here, the line has to end here, and this has to be the entirety of the middle. The entirety of the middle has to be 0 or more, not a number of characters. You can follow this general syntax whenever you want to match an entire line. Probably more often, you'll do things like grepping for the start of the line, followed by any character any number of times, followed by something you're interested in, so like hello, followed by maybe the end of the line. Or maybe you have hello anywhere, and that's right at the start of the line, or something like that. So you will often use $* in order to say, I don't really care what's in this place, but I do care that hello is at the end. And you can see here there weren't any matches because hello was never at the very end. which means hello is never directly followed by the $sign, because it was followed by things like maybe semicolons. To review some of the things that we went over today, we talked a lot about ranges. So if you want to match any character inside range, you just put it in brackets, and you can specify a few specific characters. So you can do A, B, C, and that'll match A, B, or C. You can specify a range with a hyphen. So 0 through 9 matches any number, A through Z matches any character A through Z, and A through Z matches any character uppercase A through uppercase Z. You can do a range inversion, which means that you use a caret as the very first character, and then you specify something. So if you want to match anything that is not a number, you can say not 0 through 9. If you want to repeat anything, you have any literal or any range or really anything that can match a character or a group of characters. So let's say, for example, A, followed by curly brace, and then a number. So this will match A. If you instead want to match multiple characters, you have to do it in a group. So, for instance, if you want to match hello, you would have to say group hello, followed by doing your range. And that would match the previous thing, and this thing happened to be a group 5 times. If we want to do something else that would match either the entire line, the start of the line, or the end of the line, we would use the caret for the start, or the $sign for the end. If we use both the start and the end, that's a good way for matching an entire line. If we just use the start character, then that'll just match the start of the line. If we just use the end character, that'll just match at the end of the line. And you can imagine that these characters were inserted at the very start and the very end of every line. Often, if you do use both of these characters in order to, for instance, match an entire line, you'll have to use some wildcard. So you'll have to do $* to say any character any number of times, or something like a range star, so something like not 0 through 9 any number of times. But in general, this is what you'll need in order to match the start, the end, or an entire line. Between what you know from this lecture and the last one, you pretty much know the entire basics of Grep, and you can solve any kind of basic regular expressions task. You pretty much know all that you need to know to do pretty sophisticated finds using regular expressions, whether that is in Grep or whether that's in some other language. If you want to take it a little bit further and do the actual replacing, then check out the next lecture.